So if you look at the instructions for 1 through 4, I found them to be kind of confusing because it asked for points of discontinuity. Then they asked for holes, vertical asymptotes, x-intercepts, and then horizontal asymptotes. Well, points of discontinuity are your holes and vertical asymptotes. So it's kind of like asking for the same thing twice, in a way. So I thought maybe a better way to organize your answers here would be to show it this way. So here's your number 1. F of x is equal to 1 over 3x squared plus 3x minus 18. And I would say this, points of discontinuity, POD, because math people don't like to spell a bunch of words, right? And those are made of 2 things, holes and vertical asymptotes. So I would do this, holes and then vertical asymptote, because who wants to spell asymptote? VA. And then you know you're going to have x-intercepts. And you know you're going to have horizontal asymptote. Those are the 4 things that they want. They're not asking you to graph in the first 4 problems. They're just wanting you to find these 4 things. Does that make sense? So that is how I would organize, not just for the first 4 problems, but for every problem on this worksheet. Because you have to have this information anyway. So I would get used to just organizing it this way. POD, points of discontinuity, made up of holes or vertical asymptotes. Does that make sense? Awesome. Let's go ahead and factor. Factor that denominator. What should you do first? Hey, take out that 3, you bet. X squared plus x minus 6. Now what? Yeah, let's find numbers that multiply to negative 6 and add to 1. Hopefully you're getting much faster at this. Can you factor the numerator? No, it's just a 1. Okay, so holes. How do we find holes? If it simplifies. Well, do we have any factors that simplify? No. All right, well, cool. We just write none next to holes. And then for vertical asymptotes, where do we find our vertical asymptotes? Is that in the denominator or the numerator? That comes from the denominator, right? So where are our vertical asymptotes going to be? X is equal to negative 3, and x is equal to 2. Do not just write negative 3 and 2. Those are not vertical asymptotes. Vertical asymptotes are lines. So you have to write the equation of the line, which is x is equal to negative 3. X is equal to 2. It's just like when we had to write the axis of symmetry, when we had parabolas. How many times did y'all miss a point because you didn't write x is equal to? Every time. So continue to miss points every time if you don't write x is equal to. We're not just talking about a number here. We're talking about an actual line. We graph it with a dotted line, don't we? So it's x is equal to. So yeah, what about that 3? Does the 3 have anything at all to do with your vertical asymptotes? No, because it's only the factors that have an x with them that will determine your vertical asymptotes. All right. So we're done with our denominator. We're done with our vertical asymptotes. Let's go on to x-intercepts. The x-intercepts come from our numerator. So we're going to say what value of x, if we plugged something in, would make the numerator become 0. Wait, will the numerator ever be something other than 1? No. So 1 over anything, will that ever become a 0? No. Because if you divide by 0, things explode, right? That's a vertical asymptote. Boom. So it's impossible. You could never get an output that's a 0. So that means what? Will it ever have an x-intercept? No. So there's not going to be any x-intercepts in this problem. Why? Because, look, there's no x's in the numerator. So there's nothing I could ever put in place of x that would ever make the numerator become 0. The numerator is and forever will be 1. Right? It never changes. Horizontal asymptote. This is when we have to compare the degrees. What is the degree of the numerator if there aren't any x's up there? 0. Very good. The degree is actually 0. What's the degree of the denominator? 2. All right, now we definitely refer back to our notes, right? If the degree of the numerator is smaller than the denominator, what's our horizontal asymptote? Y is equal to 0, which is also called the x-axis. And that's all you have to do for the first 4 problems, is list those 4 things. You don't have to graph them. Does that make sense? So it's just having you practice organizing and finding those 4 things. Excuse me. Any questions? So I want you to jump down to do number 4 next. I mean, you have to do 2 and 3 later, but... You have x squared plus x minus 6. Negative 4x squared minus 16x minus 12. You can actually write this out for every problem. POD, point of discontinuity, holes, vertical asymptote, x-intercept, horizontal asymptote. And that's what you need for every problem. You start realizing that the faster you can factor, the faster you can get through these problems. And this one you can factor some more. All right. And what do we find right away? Yeah, right here, right? The x plus 3 simplify. So because an x plus 3 simplified, that means we've created a hole. Where would the hole be, though? At negative 3. It's what value of x would make that factor become 0. So since that factor is x plus 3, the hole is at, bless you, negative 3. Now, if we were actually to graph this, which we'll graph one after this, right? We would actually go back at the very end and we would put an open circle on our graph. And we'll show how to do that in a minute. All right, vertical asymptote. Vertical asymptotes. Just negative 1, right? X is equal to negative 1. What about that negative 4? It's not part of, it doesn't have an x with it, right? So it doesn't have anything to do with our vertical asymptotes. X-intercepts.
2.
Positive 2. Now we just don't say positive 2. X-intercept, that is a location. That's a point, isn't it? That's at the point 2, 0. All x-intercepts have a y value that's 0. So that's the point 2, 0. All right, horizontal asymptote. We go back to the original problem before we started factoring, and we have to look at the degrees. What do you notice? They're the same. Here, degree of 2, degree of 2. So what does the rule say that we do? What do we do if the degrees are the same? We make a fraction out of the leading coefficients. Okay, so leading coefficient of the numerator is 1. Leading coefficient of the denominator is -4. So that would be y is equal to what? -1/4. Doesn't matter where that negative sign is, at the numerator, denominator, or just out front. It's going to end up being a -1/4. And you're done with those. Any questions 1 through 4? Yes. I set the factor x plus x minus 2 up here from the numerator equal to 0 and solved. So it would be just like finding vertical asymptotes from the denominator. When we use the numerator, those are our x-intercepts. Okay. Yes?
So, for like the x-intercepts, you wouldn't include the -3 because we factored it in.
Exactly, because those simplified.
Okay.
And so you see it's in the denominator as well. That's why it's a whole. It can't be a vertical asymptote and an x-intercept at the same time. They cancel out or they simplify, right? And so that's why it becomes a whole in our graph. Okay.